Alright, let's look at the practice exam 3, problem number 5. Alright, so we want to evaluate this double integral using change of variables. Alright, so let's do that. Alright, so if you look at this boundary lines, you have x minus y equals 0, x minus y equals 1. So we can set u to be simply x minus y. And the other two boundary lines are x plus y equals 0 and x plus y equals 2. So we can set v to be x plus y, right? So that's part A. And part B, we want to find the partial of x comma y with respect to u comma v. This is supposed to be a partial there. All right. So instead of finding that, we're gonna find the partial of u comma v with respect to x comma y first, because this is actually easier to find, because the equation is written as u equals and v equals form. All right, so here, so we take the partial derivative of u with respect to x, that will be 1. Partial of u with respect to y, that will be -1. Partial of v with respect to x would be 1, and a partial of v with respect to y would be 1 again. Alright, so this is just a determinant, so it's going to be 1 times 1 is 1 minus -1 times 1, so it's a -1. So this is going to give you 2. Right? But what we want is actually the reciprocal of that, so we take the reciprocal, so it's going to be 1/2. Right? Then we're gonna just rewrite this integral. Right? So you see that there's a x plus 1 in front. X plus 1 is v, so I'm gonna put v here. Right? Then you have a e to the x squared minus y squared. So we're gonna break this out. To take the factor it out as say x minus y times quantity x plus y, right? But the x minus y is u and x plus y is v, so we have a u times v. So this is just going to be e to the uv. Right, then we have to multiply by Jacobian. So we have to take the absolute value, but in this case it's already positive, so we don't really have to do anything. So it's going to be 1/2. So that's Jacobian there. All right. Then bounds are pretty easy to do. So here we have a v here. V is going to be going from, let's see, so it's from 0 to 2. So 0 to 2 there. Alright, then u is going from 0 to 1. So you have a 0 to 1. Alright, so in this case, actually, I would like to switch the order of integration because the integral is actually easier with respect to u first. So I'm going to switch them. So this is going to be, alright, so integral from 0 to 2. And the integral from 0 to 1, right? Then we have a v e to the uv, and then we're going to do with respect to u and with respect to v. All right, so this is going to be, all right, so let's leave the outside integral alone. Alright, so we're going to do the integral with respect to u. Alright, so actually I forgot the 1/2, so I'm going to put 1/2 here. Alright, so v over 2 is just going to be a number, so I'm going to just leave it outside here. Alright, then take the antiderivative of this guy with respect to u. So it's going to be e to the uv. Then you would have to divide by the derivative of that, which would be v. So we have that. All right, then we're going from let's see, from 0 to 1. So 0 to 1. All right. So you can see that we can cancel v on top here and v on the bottom. All right. Then we can just plug in. So this is going to be equal to integral from 0 to 2. All right, so u value, so we're going to plug in 1 here. So you're going to have a 1/2 is just going to be a constant. So I'll probably put the 1/2 outside. All right, so it's going to be e to the v. So you have a e to the v minus, right, plug in 0. So e to the 0 is 1. Right? Then we still have to integrate with respect to v. Right? So you have a 1/2 is just a constant placed outside. Antiderivative of e to the v is going to be e to the v minus antiderivative of 1 is v. And then you are going from 0 to 2. Right? So this is going to be equal to 1/2. Right? Plug in 2. So you have a e squared minus 2. So it's going to be 2. Minus, plug in 0, it's going to be 1 and 0. So you just get that. And which is going to be 1/2 e squared minus 3. Right? So that's the integral value we're looking for. All right, that's it. I hope that this was clear.